Hello, you absolute legends. My name is Don Cavanaugh. Let's talk about calculating the pH of a buffer solution. Consider the following. You want to make half of a liter, 500 milliliters, of a phosphoric acid buffer. So you're going to add an amount of acid and an amount of a conjugate base in an ionic compound form. We have an acid up here, phosphoric acid, and we are going to add 0.155 moles of this phosphoric acid, and we're going to add 0.250 moles of its sodium salt. We want to make a solution of 0.5 liters. If you can't already tell, we're going to do a rice table because we need to calculate the pH of our buffer solution. Our balanced chemical reaction, our initial molarities, note they're molarities, our change, and our equilibrium. We're also given a capital K value. So for young learners, recommend that when you see a balanced chemical reaction and a capital K value, you're probably going to do a rice table somewhere along the way, especially in 152. Our initial molarities for our phosphoric acid, our initial molarity for liquid water doesn't matter. Well, we don't include it in the capital K expression, so we just have an X through it right here. And this initial molarity is 0 moles per liter. The change line, how are these values going to change over time with respect to the balanced chemical reaction? This will go down by some factor of 1 from the balanced chemical reaction. This will go up by some factor of 1 from the balanced chemical reaction. And this will also go up by the stoichiometric coefficient from the balanced chemical reaction here. When we plug these into our equilibrium line, this will give us so these will be our equilibrium values for our capital K expression. Note that like when we plug these into our capital K expression, we put the products on top. And we are dropping this value, this X term, because our capital K value is so small, we can make the approximation of dropping this X term to solve for this without using a quadratic formula. Products on top, reactants on the bottom. So this is what could be evaluated and solved for. Like this is a fraction here. We can evaluate this. We're given a value for capital K. This can be rearranged and solved for X. And X is our equilibrium concentration of H3O+. But remember, we are trying to calculate the pH. So a young learner will calculate the value of X and then just call it a day. You take that value of X, plug it into the negative log to solve for pH to get your final answer. I hope this helps. Thank you.